So now everything is ready, VASP is ready, and the pseudopotential libraries are also ready. So we are also ready for our first calculation. And because we want to do a simple test calculation, we just download something from the internet. And this is a very good official website that has a wiki for VASP. This is official. And you will find a lot of different example systems, example calculations. And in this case, we use water, H2O. Yeah. And for VASP, you have 4 input files. You have a postcard, which contains the positions of the atoms, incar, which where you have the control parameters for the calculation, and k points for the k points, so to say, and podcar for the pseudopotential file. And you see that it gives the other 3 files without podcar, because podcar has copyright, so you got it with the distribution, but you cannot find it in the internet. Okay, so we just copy this postcard, and then we make a folder in the calculations. Let's say H1, H2O. Okay, and then we go to the H2O folder, and let's go to the terminal. Yeah, maybe this is easier. Okay, cd vasp calculations 1, and then we use gdit, and so what is the file? Postcard. Okay, postcard, and we copy everything here, save, and gdit incar, so this is the input file, and we copy everything from here, save, and then the k points, copy everything here, and gdit k points, save. So this is gamma point only calculation, and then the tricky part is that we need to put the podcar here, which is the pseudopotential file. And for this is H2O. There are 2 elements, and you see that in the postcard it is 1, 2 here, so which means that the first one, there is only 1 atom of this element, and there are 2 atoms of this element, so this should be oxygen, and this should be hydrogen. So for podcar, we need to put the pseudopotential file of oxygen in front, and that for hydrogen in the back. So to do that, we need to use this command. And remember, where did you put the pseudopotential libraries? And let's say paw. Oh no, sorry. So vasp paw, and we use the PBE one. And first we used oxygen, and we used the normal one without anything other than the name of the element, and podcar. Yeah, we need to combine the podcasts for oxygen and hydrogen to 1 file. And this greater sign, that is the that basically outputs the first 2 files to 1 file called podcar here. Okay, and then we run it. We can check that we have indeed 4 input files that are needed. This is a standard for all VASP calculations. Yeah, you will see later. And if you open the podcar, you will see that it starts with oxygen, and then let's just search, and then from somewhere you have the hydrogen here. Yeah, so first oxygen, then hydrogen, and this should be consistent with the things defined in the postcard. Yeah, this is important, which I will repeat later. So now we have everything. To run VASP, you can do mpi run minus mp2, meaning that you have parallel computation with 2 cores, and just go to the directory with the two files and then use vasp std. Yeah? The reason why I can do this rather than going to the full directory is that I put the environmental variable in the bashrc. Yeah, because you see because of this line. Without this line, you should mpi run -mp2 specify the full directory to vasp std. Yeah. Okay, so let's just run this, and yeah, so everything works. So this is done, and then we can go to the same folder. You see that there are a lot of output files. The most detailed one would be outcar, which contains everything. And this Aussie car contains the convergence. Basically, this is one electronic step and one ionic step, and two ionic steps and different ionic steps. So this is a relaxation calculation. And outcar contains basically everything. And count car is the relaxed structure. And actually you can extract the bound angle from this and compare it with the experiment. So I think that's all. This is just a small test, and in the next video I will show you a more thorough benchmark using a test suite tool from the internet. Okay, so I thank you for watching, and I hope to see you next time.